All right, we are looking at the final exam, just 1 through 20. This matches what is on your MyMathLab, 1 through 20. It doesn't exactly match the final review that I've given you before because we're leaving a lot of them out. So number 1 on the review we're omitting. So number 2 on the final exam review, which is number 1 on your MyMathLab. So not real sure how to number these because we've got 2 different systems of numbering going on. So this is actually the first one of the MyMathLab, and that's probably easier for you to use. Okay, we've got a radical here. We want to solve for x. We're going to need to get it isolated, so move the 8 out. You got the square root of 2x equals x minus 4. This is from section 1.6 in your book. Let's see what we're going to do next. We need to isolate x here. So let's get him out of that radical. Squaring and unsquaring cancel each other out, you know. So we end up with 2x here. This is a quadratic, x minus 4 written twice, x minus 4 times x minus 4. So first, outside is a negative 4x, inside is another 4x, and then the last, and you can do that out if you need to. Then we need to get a 0 here. Once we see this x squared, we know we've got a quadratic equation we're going to have to factor. So 0 factor property is what we're going to use. Let's move the 2x over there. Factor it. Signs need to be the same and they'll need to be negatives. And then what 2 numbers multiply to give you 16 that add together to give you 10. It's 2 times 8 and 2 plus 8. And then use the property that allows you to separate them out. We get those 2 answers. I'll remind you that if you've got a radical in the original problem, you have to check your answers. So let's check our answers. Putting a 2 in here, the square root of 2 times 2 plus 8 equals 2 plus 4. Let's see, that's the square root of 4, which is 2. 2 plus 8 is 10, equals 6. Not exactly. So where is it? That one doesn't work. Let's try 8. So we're going to put 8 in there. 2 times 8 plus 8 equals 8 plus 4. And work that out and see that it works. We've got the square root of 16, which is a 4. 4 plus 8 equals 8 plus 4. Good. So you get one answer out of that. So in your multiple choice exam, your final exam is completely multiple choice. They're going to offer you 2 and 8. They're going to offer you 8. They're going to offer you 2, and they're going to offer you the null set. Think about why they're doing that. Look at the answers, every single problem you do. If you've got 2 answers and they're offering you some situations where only one of them is acceptable, why are they doing that? I'm hoping that that will prod you to remind yourself that with radical problems, you have to check your answers. Okay, the next one that we're doing, this will be number 2 on MyMathLab, and it comes from 1.6 also. X plus 3 in parenthesis raised to the 3/2 equals 216. Okay, we need to get x by itself, so we need to free them from those parentheses. So what we're going to do is raise this phrase to his reciprocal. 2/3 raised to the 2/3 power. The 3's will cancel, the 2's will cancel, and we'll get x plus 3, which is what we want. If you've done that to one side, you have to do it to both sides. So we'll also raise that to the 2/3 power. Couple of ways of getting this done. You can put in 216 raised to the 2 ABC3 power, and you'll get 36 out of that. So we're going to get a 36. Or you can know that you need to put 216 under the radical. The denominator is the index, and then we'll square it. So you're doing the cube root, and then second humpy of 216 equals 6. And then we're going to say 6 squared, which you know is 36. We're still solving for x, So move that across. X equals 33, and that's a good answer. The next one we're looking at on your final review on MyMathLab is number 3, and it comes from section 2.2. We're being given f of x equals, and then we've got a little piecewise function here, negative x plus 3 if x is less than 2, and 2x minus 3 if x is greater than or equal to 2. You'll be asked on your final, I know it's not the same as what you're being asked if you're looking at the great big 54 question one, but on your final and on your MyMathLab final, you'll be asked something like to find f of 0, let's say. What you want to do there is you want to find out which category 0 lives in. Is it less than 2 or greater than or equal to 2? Well, you know that 0 is less than 2, so this is the game you want to play. Negative x plus 3, put in 0, negative 0, there's no such thing, so we just get a 3. So the answer there would be just 3. So that's, I know that number 3 on this review asks you to do more, but that's all I'm going to ask you on the MyMathLab review and on the final itself. All right, let me pull it all the way down here. I think we got room. Let's make some room here. Okay, that was number 3. Number 4, we're looking at finding the domain. This problem is from 2.6, and it gives you h of x equals x minus 2 over x cubed minus 36x. And you're asked to find the domain. We've got several domain questions here. Domain means what are you allowed to use for x, and that is only dependent on making sure that the denominator does not equal 0. You've got to make sure to stay away from 0. So let's set it equal to 0 and see what happens. 36x cannot be 0. We can factor out an x there. We've got x squared minus 36 equals 0, or shouldn't equal 0, let's say. Then we can factor this inside. This is a difference of 2 squares. So you get x plus 6, x minus 6 there. And these are the numbers that we cannot use. These are the ones that the domain will not be allowed to use. So x cannot equal 0. X plus 6 cannot equal 0. And x minus 6 cannot equal 0. So here we have one of our no-nos. Move the 6 over, and you see that it cannot equal negative 6. Move the 6 over, and you see that it cannot equal positive 6. So those are our 3 no-nos. If the question asks you, I mean, you look at the answers. If the answers have 0, negative 6, and 6, that's your answer. But it is quite possible that you will be asked to write it in interval notation. And I always think writing it in interval notation is easier when you first look at a number line. So let's put these 3 numbers where they belong on the number line. I know that I can't use negative 6, but I can use everybody over there. I can use everybody between negative 6 and 0, everybody in there, and everybody out there. Just not 6, not 0, and not negative 6. So the answer here would be, we can go from negative infinity to negative 6, union up with negative 6 to 0, union up with 0 out to 6, and then union up 6 to infinity. So it's kind of a long answer. You're finding a match to that. You're not having to write that out yourself on the final. All right, number 5 on your 1, 2, 3, 4, 5, good, keeping up, on your MyMathLab homework is from 2.6 also. It's asking you to find f minus g. So we've got f of x equals 6x minus 4, and g of x equals 8x minus 9. We're asked to find f minus g. So let's get f. F is 6x minus 4. Then we're asked to subtract g. All of g. I'm going to put it in parentheses because it's not only 8x are we subtracting, but we also need to subtract 9. And that's the key to getting this one right. You have to know you've got to distribute the negative. So it becomes 6x minus 4 minus 8x plus 9. Look for like terms. And there's your answer, 14x plus 5. Number 6, you're asked to find g composed of f of x when f of x equals x minus 5 over 7 and g of x equals 7x plus 5. Getting in there? Yeah, good. Okay, so we're asked to find g composed of f of x. So let's start on the inside, start with f of x. So we're taking our x minus 5 over 7, and we're going to take that with us to the g function. So this entire piece is going to slip into place right there. So g composed of f of x is going to look like 7, then it says times x plus 5. So there, and that's a 7 right there. So we're placing this piece, the f piece, into the g equation. I see that the 7's will cancel out, so we'll get x minus 5 plus 5, which just gives us x. Let's see. Number 7 comes from section 6.3. And it is asking you to identify x, y, and z. It's a matrix problem. X plus 3, y plus 4, 7, 3 equals 9, negative 3, 7, and z. So we're asked to find x, y, and z. This is really simple. This is a 4 by 4, or 2 by 2. This is a 2 by 2. So x plus 3, the first piece, the first term, matches to the 9. Y plus 4 matches to the negative 3, 7 matches to 7, who cares, and 3 matches to z. So let's find each of them. X plus 3 equals 9, move that 3 over, so x equals 6. Y plus 4 equals negative 3, move the 4 over, so y equals negative 7. And then 3 equals z. So there are the 3 answers. 6, negative 7, and a positive 3. Okay, number 8 is asking you to use the square root of x. This comes from section 2.5. Asking you to use the graph of the square root of x. That's a shoulder, remember. And you're asked to graph negative square root of x plus 1 plus 2. So what we're going to do is we're going to start out with the basic shoulder. The shoulder goes through 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 3. Remember, you're matching to a graph, so you don't need to get all that detail in there. So it looks something like that. Okay, then the vertex point of this thing, which corresponds to the neck, the vertex point of this, remember this is always a liar, and this will be the same. So the vertex point of our new shoulder is going to be at negative 1, 2. Negative 1, positive 2, right there. Problem is, well, we end up with the same thing, so it's good. But what we'd normally do is we would do the horizontal shift. So we'd move it over here. Then we would reflect it about the x-axis. So it would be down like this. And then we would raise it up too. So it's no matter what, we're going to end up with something like that. The blue one is the new graph. You can either do the vertex point and then reflect it across the new axis there. I can see where you might get confused on that. So let's do the horizontal shift first, negative 1, then the reflection, so now it's doing this, and then move it up to boom, boom, like that. All right. That's number 8 on my math lab. Number 9 is another domain problem. Number 9 comes from section 2.6, and it's asking you to find the domain for the function f times g. You can see that f of x is the only one that's got a denominator. So all we've got to worry about is that denominator. We've got to make sure that that denominator, x plus 7, does not become 0. Move it over, and that says that x cannot be a negative 7. Doesn't matter what's happening on g because it doesn't have a denominator. Or if you remember, a radical. We worried about a radical also. We're not worrying about it on this test or on the final. So again, just like this problem, number 4, where it asked you for domain, they might just ask you for the numbers. They might ask you for interval notation. So you just have to see what the answers are doing. So either negative 7 is not allowed, or you would be saying all of that's good, not that one, and all of that. So that would look like negative infinity to negative 7, union negative 7 on out to positive infinity. Number 10 is another graph. This one comes from 2.7, and they're asking you to draw the inverse of this graph. So let's look at what this graph is doing. I'm looking at, Annette Thurlow's final thing. Let's see. Looks like it starts at negative 1, 2, 3, 0. Haha. Right there. And it looks like it goes across the y-axis at almost, well, I see where I like the point better. 1, positive 2. 1, positive 2. Looks like it goes exactly through that. So something like that. Maybe not quite as high as that, but that's good. Not a big deal. Remember, you're matching. Okay, so on this problem, if we're trying to do the inverse, we want to draw the shape that is the mirror image across the y equals x. Across that line, the y equals x line. I think the easiest way is to grab a couple of the points. This point right here is negative 3, 0. This point is 1, positive 2. If we're worrying ourselves about an inverse, we're just going to swap those numbers out. So 0, negative 3, and 2, 1. The y's get up and move into the x spots. The x spots get up and move into the y spots for inverse. So let's graph these 2 points now. The first point is 0, negative 3. 0 says don't go sideways. Negative 3 says go down. And then over 2 and up 1. So this, whoops, I missed it, but it needs to be going through that point right there. That is the reflection of the black one across a diagonal line. So that's the inverse. That's what you're looking for in your multiple choice answers. All right, number 11 comes from section 2.7. It says find the inverse of the one-to-one function. So we're told f of x equals 5 over 7x minus 1. So we're looking for the inverse. I'm going to first make this y. Then I'm going to swap out the x and the y. Then I'm going to start solving for y. I want y to be by itself. So the first thing I'm going to do is put this over 1 and do some cross multiplying. So x times 7y minus 1 equals 5. I'm going to divide by x. So I get 7y minus 1 equals 5 over x. Then I'm going to add 1. So I get 7y equals 5 over x plus 1. And then I want to divide by 7. I'm going to have to divide that guy by 7 and that guy by 7. When I'm dividing this side by 7, I just let the 7 join in the denominator. And then this one was just a 1. So we get y equals 5 over 7x plus 1 over 7. And then the final step to making it an inverse is to call this f of negative 1 of x. And there we go. Yeah, you can see that. Okay. Number 12. Let's see. Okay, 12 comes from section 3.2. It's asking you to find the zeros for the polynomial function and give the multiplicity for each zero, and then state whether they cross the x-axis or touch the axis and turn around. So what you've got here looks like this: 3x plus 5, x minus 5 squared. Okay, this is as close, what I got on my math lab to number 12 is as close as I could find. It's still got, you have to do the factoring here. So it'll already be, it'll be multiplied out. You will have to break it down to find those. So factor it first, then you'll be looking at this. And then, well, this is not an x, so you don't have to worry about that guy. Let's grab the x plus 5. So x equals negative 5. So the first zero is negative 5. It has a multiplicity of 1. It's only, the exponent out there is a 1. And then because it has a multiplicity of 1, we know that it's going to cross through the x-axis. It's going to go screaming through the x-axis. This, x minus 5 equals 0. Move the minus 5 over, and we get 5 as a 0. It has a multiplicity of 2. And that means that it is going to go to the x-axis and bounce. What do they call that? Touches the x-axis and turns around. So it'll touch the x-axis and turn around right there at 5. So touch and turn. Okay. Number 13. Use the rational zero theorem to list all possible rational zeros. Okay, so we have got f of x equals x to the 4th, and then the last one is a minus 12. So you got all this other stuff in here that you don't have to worry about. In order to find the rational zeros, remember the numerator, to find the zeros, the numerator is going to be all the factors of 12. So plus or minus 1, plus, well, 1, 2, 3 will go in, 4 will go in, 5 won't go in, 6 will go in, 7 won't go in, 8 won't, 9, 10, 11, and 12 will go in. Then you divide that by the factors of the leading coefficient, which is just a 1. If this had a 7 there, then we'd have to go through and do 1/7, 2/7, 3/7, 4/7, 6/7, 12/7, that kind of thing. But it's just a 1. So we end up with plus or minus on all of these numbers, 2 plus or minus 3. These are all the rational zeros that are possibilities. They won't all go in, but some of them will. Those are the ones to choose from. Number 14, let's see, 13 comes from section 3.2. Number 14 comes from section 3.4 and is asking you to use the rational zero theorem to list, we just did that. How about, let's see, let me back up here. So 12 is, I got a different numbering system on this sheet than what I've done for you guys, so it's a little bit confusing. So this is number 13 is that, and that is 3.4. And then the next one, this is also 3.4. This is number 14. Okay. I feel like I must have missed a problem in here because I thought it was 1 off. It looks like I'm 2 off from my count. Hang on a second. No, looks good. Okay. So number 14 says, this is like number 16 on the 54-point question. find a rational zero and use it to find all the zeros. Okay, so we have got f of x equals 4x to the third minus 19x squared plus 19x plus 6. So, using the previous problem to find what the possibles are, we know that what goes into 6 is 1, 2, 3, and 6. What goes into 4 is 1, 2, and 4. So our rational zeros, our total possibilities, are 1 over 1, 2 over 1, plus or minus 3, plus or minus 6. And now let's try 2 over 1. Well, we've already got that. 2 over 2, we've got that. 2 over 4, that's 1/2. 3 over 1, we have that. 3 over 2, we don't have that, so plus or minus 3/2. And 3 over 4, we don't have that. 6 over 1, we've got it. 6 over 2 is 3. 6 over 4 reduces to 3 over 2, and we've got it. So these are the numbers we get to choose from when we're going to do synthetic division. So let's see, 4, negative 19, positive 19, and 6. I'm just kind of feeling it about 2. I'm not looking at my notes right now, so I don't know, but we'll see. 4 times 2 is 8. That gives us a negative 11. This is looking better. Negative 11 times 2 is negative 22. Add those together, you get negative 3. Multiply there, and we get a 0. That's cool. That means that this worked. So we're left with 4. This was x cubed to begin with, so now it'll be x squared equals 0. We're still working on factoring this. So we found one of our numbers. Let me not lose that little guy. There's one of our zeros. 2 works. Let's find the others. I'm going to try 4x and x because I want to get 11 out of this. There, I can get 12 of them right there. So let's see. We're going to put the 1 there. Signs need to be different, and I want this to be negative. So I'm going to put the negative there. So that gives me a negative 12x and a positive 1x. That'll give me that. So you're just factoring there. 4x plus 1 equals 0. X equals 3. There's another one of our zeros. And then move the 1 over and divide by 4. So there's our other 0. So negative 1/4 and a positive 3 and the 2. We've got 3 zeros there. Okay, number 15 is looking at, is it a one-to-one function? They're telling you you've got a function. That means that it will obey the vertical line test, no problem. But they're asking you, is it a one-to-one? Meaning, does it obey the horizontal line test? Does it pass the horizontal line test? So if I run a horizontal line test right through here, beep, that's okay, 1 is okay, beep, it hits again. So this flunks the horizontal line test, which means it is not a one-to-one function. And that problem comes from section 2.7. Let's look at number 16. See, we're looking for an nth degree polynomial function with real coefficients satisfying the given conditions. Okay, the given conditions are that we're going to have 3 answers. We're told that negative 6 is a good answer, and I is also a real 0. And then we're told that f of negative 3 gives us 60. Okay, so the setup for this is to say that f of x equals a. That'll come into account way later. We'll worry about that at the very end. We need 3 sets of parentheses here for the 3 zeros. Negative 6 is 1, so that'll be x plus 6. Remember, in here, next to an x, it's a liar. So that takes care of the negative 6. The I will be x minus I, and you're told that if you've got a non-real 0, then you've also got his opposite. So there's his opposite. We're going to FOIL these 2 out first. Always FOIL the ones that have not real bases. So first gives me, I'm foiling this, first gives me x times x is x squared. Outside is a plus xi, inside is a minus xi. Those will cancel, I don't have to worry about those. And last is a negative times a positive is a negative. I times I is I squared. Remember that I squared is a 1, negative 1, sorry. I squared is a negative 1. So we've got to multiply these now. So we get x squared plus 1. Now let's bring in our x plus 6. Let's not forget our a, and f of x equals. Okay, let's continue multiplying these together. So I'm going to FOIL these. X times x squared is x to the third power. The outside is a plus x. The inside is a plus 6x squared. And the last is a plus 6. So there, that's multiplied out. We are told up here, comes the last bit about the a, we're told if you plug in a negative 3 here and here and here, you should get a 60 over here. So let's do it. Let's say 60 equals a times, then we're going to plug in a negative 3 cubed plus 6 times negative 3 squared plus negative 3 plus 6. Negative 3 cubed is a negative 27. Negative 3 squared is a positive 9. Times 6 is 54. So 60 equals negative 27 plus 54 is 27. 27 minus 3 is 24. 24 plus 6 gives us 30. We want to solve for a, so divide both sides by 30, and we get a equals 2. So we're going to put that 2 back in right here. Here is where we have developed this whole big old thing. Right there. We're going to put the 2 right in for a right there. That's the way they want it to look. So f of x equals 2 times x to the third plus 6x squared plus x plus 6, and let's go ahead and multiply it out. 2x to the third plus 12x squared plus 2x plus 12, just distributing 2 across all of those. So that's what you're looking for. I know it's a little bit long, but you can use your review notes on the final. So do use your review notes on the final. All right, I think we need to clean this up. Let's see, we're on number 16 for that one. So the next one's going to be number 17. Okay. Get us a new sheet of paper. Okay, this is your final review. We move you up. Final review, and we are doing 17 through 20 on this page. Okay, so number 17 is from section 3.3. And it's number 19 if you're looking at Annette Thurlow's 54 question review. Solve the equation 2x cubed minus 17x squared plus 31x plus 20 equals 0, given that 4 is a 0 of that equation. So let's work it out and see what's left. 2, negative 17, 31, and 20. 2, bring it down, 8. We get a negative 9 there. Negative 9 times 4 is negative 36. It'll give us a negative 5. Negative 5 times 4 is negative 20. Sure enough, it's a 0. It gave us a 0 for the remainder. So we're stuck with 2. This was x cubed. So now we've got 2x squared minus 9x minus 5 equals 0. We're having to factor that. 2x and x. The signs need to be different. And then we're multiplying 5 times 1 to get 5. I'm going to put the 5 back there. That'll give me 10x. That's close to what I want. And there we go. So it's an outside negative 10x, an inside plus 1x. Good, got the middle term. So set each of these equal to 0 and solve them. X equals a positive 5, that's a 0 of ours. Move the 1 across. Negative 1/2 is one of our answers. And don't forget 4 up there. He's also one of our answers. Number 18 comes from section 3.2. And you're asked to use the leading coefficient test to determine the end behavior of the polynomial that you're being given. Then use the end behavior to match the function with its graph. So the one that you're given here, f of x equals negative 3x squared, that's really all you need, but I'll write the rest of it down. Okay, so we are looking at the leading coefficient. Right here, we're looking. X squared tells us it's a parabola. It's an even number, so we know that the end behaviors go up. It rises up to the left and up to the right. But we have a negative there, so that's going to flip it around. So it means that we're going to be falling to the left and falling to the right. Then you go find the graph that falls to the left and falls to the right, and that's the correct answer. That's all they're looking for there. Okay, number 19 comes from section 2.6, finding the domain. Boy, done that a few times. In this particular problem, x plus 4, nobody cares what the numerator's doing. You only care about the denominator. You can't have it equal 0. So let's see what we got here. I can factor out an x. Can't equal 0. And I'm done. There's no more squares. I know this is a little bit, not confusing, but a little bit tempting to turn this x squared minus 25x into x plus 5x minus 5. But that x needs to be GCF'd out first. It's got an extra x that's not normal in a difference of two perfect squares. Then you're down to x to the first, so there's nothing happening there in terms of x plus 5 and x minus 5. Set each piece equal to 0. So we know one of our no-nos. The other one, move the 25 over. X cannot equal 25. So those are our two no-nos. If they ask you which ones cannot be used, that's your answer. If they ask you to do it in interval notation, you're good for anything over there, anything between them, anything to the left. Not 0, not 25. So we've got negative infinity to 0, union 0 to 25, union 25 to infinity. Got all three of those gaps, 1, 2, 3. Two numbers, break it up into 3 parts. And then the last thing you got to worry about for the first 20 is in section 3.5, and you're asked to find the vertical asymptote of x over x squared minus 4. This is another game where it's very much like what is the domain. In order to find the vertical asymptote, you are just looking at what you cannot use for the denominator, what will not work. This is the difference of two squares, so we'll set this up as x plus 2. Yeah, kind of blew that. Okay, x plus 2 and x minus 2 there. So x plus 2 equals 0, x minus 2 equals 0. Move the numbers over, and they're the two bad guys. The two vertical asymptotes are x equals negative 2 and x equals 2. To remind you, that means that you would not be hitting that line and you would not be hitting that line. You might have something doing like that or this or something like that if you had a horizontal asymptote, but you could not cross those vertical asymptotes. Okay, that's 20. I'll see you on part 2.